Hi everyone, today I will introduce you a method to evaluate the iteration. One of the most famous to evaluate the iteration is the substitution. Today I will introduce you this method. We could call this method is the substitution rule. To use this substitution, when we have the iterations of fs and f that s ds. F dash s is the derivative of fs. So we could change to another variable that's we could set t equal fs, and we will find the derivative of t dash equal 1, so we could combine with dt equal f dash s ds. So the iteration could put it right like this, and we could change fs by t and f dash s ds by dt, and we could integrate this iteration by the formula t square over 2. Let's see. We see. We usually use this method when you can see we see the radical, the square root, cube root, and when you see the power fraction, power like this, or a fraction like this, fs, f v g, or the any function could derivative by another function, and so on. For example, when we want to iteration of the function square root 2s plus 1 s ds. We could see this iteration by cube root. We could use cube root. So we could substitute t by cube root, and before the derivative of this function, we could cube two sides, so we can get t cube equal to s plus 1, and we will derivative these two sides by t cube derivative. We have 2t square dt equal to ds, and we can see that s we will change to a new variable that's t. So we could keep two sides from this or from this. So from this we can get s equal a fraction of t cubed minus 1 over 2. So we can and we will change divide by two sides of this equation. So we could get 2 over 2 t squared dt equal ds, and we will rewrite this integration like this. Integration, the cube root we could replace by t, and s we could rewrite by this. And ds we could rewrite by this. And as if a constant we could give before the iteration, so is equal 3 over 4 integration of t times t squared equal t cubed multiply t cubed minus 1 dt, and we will multiply this function to before integration by the integration of t power 6 minus t cubed dt, and we will use this formula. The integration of x power n ds equal x power n plus 1 over n plus 1. So we could integrate this function like this: 3 over 2 over 4, and t we will increase the power of t 1 unit, 7 over 7 minus t power to 4 over 4. Let's see, and we will substitute t by the initial function, so we could get we substitute t by this function, and another t is 2. And here's the iterations of the function. And another examples, we could have, for example, iteration of size qs multiplied by cosine s ds. we could see that sin derivative equal cosine, so we could get t by sin, and we will derivative differences, so we get dt equal cosine ds, and we could rewrite this integration by integration of t cube cosine s ds, we could replace by dt, and we get the integrations of this equal t bar over 4 plus c. Yes, and we replace t by sin, so we could get sin bar for s over 4, let's see. Another example is the integration of e power s square time x ds. And we could see that if we put t by s square, and we could get the derivative of t equal dt equal to s ds, and we will we can see that the integration of s ds, so we divide by 2 this equation, so we could get 1/2 dt equal s ds, and we will change the integration by a new formula. The integration we keep like this, and e power to t s ds we could replace by 1/2 dt, and we could put the constant before the integration, so we could get the integration of e power t dt, and the integration of e is called the same function, so we could get e power to about to t, and let's see. So we returned initial function, so we could get e equal t replaced by x square. Let's see. And another example is a fraction. For example, the integration of a fraction like this s ds is s square plus 1, and we could see that s square derivative equal to s like this, so we could set t by s square plus 1 equal s square plus 1. So the derivative of this function is 2s equal to s ds, and we will divide by 2 to solve this equation. We will could add s ds. And then we could derive this integration by the form integration direction insert the same ds sds we could rewrite by 1/2 dt over s square plus 1 we could replace by t. So the integration of the function is ln t, and the constant we could put the front of this function and t, and the we have the absolute to ensure this is greater than 0, positive, and we return this function t by s square plus 1. So we get absolute of s square plus 1 equal, let's see. So this is enough for today. Another video I will show the applications of integration and the rule of definite integrals by change the value of integration. And goodbye. Remember to subscribe for next video. Thank you.